Back to using subject-verb agreement to study the behavior and grammatical capabilities of neural language models. Gulordava et al. Made two important contributions extending the work in this area using, first of all, not only English, but a number of other languages as the test languages that had subject-verb agreement. This included Russian, Italian, and Hebrew. Examples are shown here. They also looked at not only existing corpus-based materials, but created more challenging tests for artificial models by creating sentences that were novel and didn't actually make semantic sense, but still were syntactically well-formed. We'll see how that works here. First of all, they used dependency structures in a dependency annotated version of Wikipedia text by automatically parsing the text, and then using these kinds of patterns of identifying a subject-verb relationship or other relationships that induce agreement in these languages, and then extracting the patterns, including a focus on having intervening contexts that might have attractors in it. Once they did this, they then took these patterns that they had extracted and these existing sentences and took the originals, but also sometimes converted the originals to versions that we'll call colorless green versions. This is a reference to the famous sentence originated by Noam Chomsky in the 60s, colorless green ideas sleep furiously. These are word-word combinations where the bigrams are extraordinarily implausible and certainly would have extraordinarily low probability. Furthermore, the sentence cannot make semantic sense, but it is recognizable as a sentence that is well formed by the rules of English syntax. And this was once again a demonstration of the hierarchical structure and the productivity of human grammatical knowledge. Gulordava et al. Created colorless green versions of these sentences by systematically substituting content words for other random content words while preserving parts of speech. So for example, a sentence in a corpus like "it presents the case for marriage equality in states" might be converted, random substitution of function word of content words, to something like "it stays the shuttle for honesty, insurance, and fines." As before, the challenge in the original sentence would be correctly predicting the number form of states. For the nonce sentence, it would be correctly predicting the number form for fines. And this created sentences of original type and colorless green or nonce types. So for example, I guess the question on which I should like your steer is or are. The main thing people do here is or are. The first thing you notice when you arrive on location is that the waiting line literally goes out the door and spiller spills. Please let me know if you have any questions or need or needs. And remember here, this has to be a verb. So if it's a verb, what is the form that it should have? But here are some examples of non-sentences. The ecological wines we believe in our night, assume or assumes. You assume the picketing and seeker seeks. The sauce to recruit in pastor, advisor advises. Can you expire that the ground we are happening, producer produces? And you can take a moment here, you can pause the video if you want and determine your predictions and see if the original sentences are easier or harder than the colorless green sentences. These are the correct predictions. And now we'll see the behavior of artificial models and of humans, because they also collected human performance by forcing people to do this experiment that I just had you do for a moment. So what they did is they took Wikipedia text from each of the languages that they looked at, took 90 million words per language, fed it into an LSTM model, optimized the LSTM model fairly well, and then looked at both human performance and compared it to LSTM performance. And you can see that, and this is the breakout by number of attractors, you can see that as before, having more attractors makes things harder, but actually this model does much better than the original work of Linzen et al. There's still speculation as to why, but it seems to be that this is a very well-tuned LSTM for grammatical performance. You can see that the human behavior actually is explicable in largely similar ways as the LSTM behavior is. So for example, having two attractors makes things appreciably more difficult for humans and for LSTMs than having no attractors. Furthermore, having no attractors is not too bad even for nonce sentences, as you can see. So there's a little bit of a performance hit, but performance is still above 90% in the zero attractor nonce sentence case. But you can see that the performance hit is much more substantial with attractors. for non-sentences than it is for original sentences for both the human and the LSTM. Interestingly, the LSTM actually performs just about as well as humans for the two attractor cases, but the humans seem to have an advantage in the one attractor case, certainly for the original sentences, and even more so for the non-sentences. They also do a breakdown by different kinds of structure, different kinds of syntactic configuration as well. And if you find this something you want to look into more deeply, I'd recommend you read the paper. It's a really neat paper.